Hello all. In this lesson we're going to be studying heat calculations. You do need a calculator, so if you don't have one, get it now. And a reference table, you're going to need that as well. There's a bookwork associated with this lesson, so we'll do that in class when I see you. And the aim is what is heat. So start a separate piece of paper for classwork that includes this aim, what is heat, and this particular bookwork header. And then underneath that, copy down these do now questions. You should have this done before class. So we're going to do the heat equation in this lesson. And you might be wondering what this beautiful, beautiful feline is doing on the page, but it's because that's a cat. And the equation that you're going to learn is Q mc delta T, and I think this looks like a cat, so that's why I say that. All right, so an example of a question you're going to have to learn to solve is right here. How many joules of heat energy are released when 50 grams of water are cooled from 70 to 60? That's awfully specific and probably really confusing, and many of you are thinking, how on earth am I going to solve that? So it's much simpler than you might think. You just need to identify variables in a reading question, and then you'll be able to plug them into this equation and do some pretty simple algebra to solve. So what do all these symbols mean? Well, Q means heat, and it's measured in joules, and you do need to write that down. So Q means heat, and it's measured in joules, at least the part that I underlined. M means mass, and it's measured in grams, so you need to write that down. C means specific heat. You need to write that down, and it's measured in joules per gram degrees Celsius. And actually, on your reference table, it might also be listed as joules per gram Kelvin, just like the temperatures that we learned yesterday. So you can say it either way because a Celsius degree and a Kelvin degree are the same size. Also, specific heat has an actual value, at least for water, that's listed on your reference table. I believe it's on table B, physical constants for water. Let me know if that's not true. But the value for specific heat for water is 4.18 joules per gram Kelvin. I want you to write that down as well, even though it's on your reference table. And then lastly, delta T means change in temperature. Its unit is Celsius or degrees Celsius. It could also be Kelvin. There's no rule against that, again, because Celsius and Kelvin degrees are the same size. So now that we know what all the variables are, Q is heat, M is mass, C is specific heat, and delta T is change in temperature, and we know their units, joules, grams, joules per gram Kelvin, and Celsius, then we can move on and start solving things. All right, so when you use Q equals MCAT, you can only use it when a substance is heating up or cooling down, and never while it's undergoing a phase change. Please be absolutely certain that you write this down. And I'm going to draw a diagram for you to copy as well. Okay, so here's the diagram that I was talking about. I'll zoom in a bit for you. I was saying that you can use Q equals MCAT when the substance is heating up. So that's all of the blue check marks. So this is a solid, which is increasing its temperature. You can use Q equals MCAT there. In the second section, we have a liquid, which is increasing in temperature. So you could use Q equals MCAT there. And lastly, we have gases that's increasing its temperature. So you could use Q equals MCAT there. When you cannot use Q equals MCAT is here and here. And the major reason is because in this section we have a phase change, and there's no change in temperature during a phase change. Similarly, during boiling we have a phase change and there's no change in temperature. The reason why you can't use Q equals MCAT for those sections is because it involves the variable delta T. And delta T is the change in temperature. So during phase changes, the change in temperature is 0 degrees Celsius. And that means that all of your values for Q would come out to be 0, because if you're putting a delta T of 0 here, then 0 times anything is going to be 0. That's the reason why you can't use Q equals MCAT here or here. We have special equations for these two, and I'll teach you those tomorrow. So why can you only use this equation while it's heating or cooling a substance? That's because you need to have a non-zero value for delta T. Okay, I think we're ready to do an example. This question says, how many joules are absorbed when 50 grams? And I want you to start labeling, as you see these values, label them with what they are. So 50 gram, that's the unit for mass of water. When they say the word water, that means we also have the value C, specific heat capacity, are heated from 30.2 to 58.6. These two values together will give me delta T, the change in temperature. And joules, of course, is Q. So we're looking for Q. All right, identify the known and unknown values. The things we know are M, C, and delta T. And the things we don't know are Q. That's good, because in algebra, you're only really supposed to not know one of the things. All right, and then we need to substitute known values into the formula. So Q equals MCAT, right? So we're going to put in the values that we know. M is going to be 50. C is on your reference table B, and it's 4.18 joules per gram Kelvin. And delta T is 58.6 minus 30.2. So I simplified the terms in the parentheses to 28.4. And lastly, I just need to solve and assign the correct units. So we'll do that now. And I got the value 5,935.6. Of course, I could use significant digits on this, but I'm not going to spend time on that in this lesson. But there are a couple things that we can do that are pretty helpful. One of them is to, instead of expressing this answer in joules, we could express it in kilojoules, in which case you would need to divide your answer by 1,000 or move the decimal 3 places to the left. So I would get 5.9356 kilojoules. And you could also express this in scientific notation, which needs to have only one digit to the left of the decimal, or in other words, it needs to be between 1 and 10. So it would still be 5.9356 times 10 to the, third joules. So all of those are acceptable, and if the answer is really large, definitely consider reporting your answer in kilojoules or in scientific notation. And when you have a multiple choice, then you don't have a choice. You have to choose the one that's correct, and if they choose to express it in kilojoules or scientific notation, then that's their choice. All right, so we've made it to some MCAT practice. I'm going to solve each of these questions one by one, and then I will discuss how it happened. Okay, so when I read the question, I saw when 25 grams, so I knew that was a mass, and I recorded a mass here. So when 25 grams of water are, and then it says water, so now I know the value for C, so I recorded it here. And are cooled from 20 to 10, so I know that's going to give me my delta T, so I recorded it there. And then it says how many joules of heat energy are released, so they just talked about Q. So now I know my Q, or I know I'm looking for Q. So in my next step, all I had to do was write down the basic equation, and it was already arranged to solve for Q, so I just substituted values. And after executing the operations, I got 1,045 joules. I did not take care to make sure this was in scientific notate, or that this was in proper significant digits, so I will go over that in class if you guys need help. All right, I'm going to do the second one now. All right, so I'm going to read the question and label things as I go. So the temperature of a sample of water in the liquid phase. So when they said water, I know that's C. So I have my value for C, 4.18. In the liquid phase is raised by 30 degrees Celsius. So this is my delta T. They just told me straight away that the change in temperature is 30. So I just wrote delta T is 30. By the addition of 3762 joules. Joules is a unit for heat, so that means they gave me Q. And that also means I'm missing my mass, and that makes sense since the next sentence says, what is the mass of the water? So now I know I'm looking for mass. This did change the way I approached this question, because the standard equation reads Q equals MCAT, but I need to isolate M. And what I need to do is inverse operations. Since M is multiplied by C and delta T, the way to isolate M is to divide both sides by C and delta T. So I did that here. I divided the right by C delta T and the left by C delta T. On the right-hand side of the equation, the C delta T's cancel each other. So you are effectively isolating M if you say that M is Q over C delta T. And that's what I wrote here. M is Q over C delta T. From there, you need to substitute in values from your inventory. So I have 3762 over 4.18 and 30. And all you need to do is execute those operations and you get M is 30. The unit would be grams because it's a mass. All right, I'm going to solve the third question now. Okay, let's start by reading the question. I see when 418 joules, this is a heat, are added to 10 grams, a mass, of water, that gives us the specific heat capacity, at 20 degrees Celsius. So it's at 20 degrees Celsius, that means we can call this our initial temperature. But they want to know the final temperature of the water. So change in temperature is what happens in between the initial temperature and the final temperature. And the equation Q equals MCAT really only solves for change in temperature. So there is another way to do this one, which I consider more complicated. And the way I'm going to do it on this video is the way I think is best for most of you. And I'm going to solve for delta T. So I have a Q, I have an M, and I have a C. And I'm going to solve for delta T, even though I know that what they really want me to find is TF. So at the end, once I've solved for delta T, I'll do some extra stuff to find the final temperature. Okay, so you start from Q equals MCAT, which is the standard equation. And we're looking for delta T, so you have to isolate delta T, which means you have to undo what's being done to it already. In other words, inverse operations. So right now, delta T is being multiplied by both M and C. So I'm going to divide delta T by M and C, but I have to do that on both sides. So I've divided both sides by M and C. And now I have delta T as Q over MC. And plugging in values, I get 418 as my Q, 10 for the mass, and 4.18 for my specific heat capacity. And executing those operations gives me a change in temperature of 10 degrees Celsius. But remember, I was actually needing final temperature, not change in temperature. So I set up a very simple equation. To find the final temperature, you just need to take the initial temperature and add the change. And I'm adding that because it says the heat was added, because there are cases when you might subtract. But my initial temperature plus the added temperature is going to give me the final temperature. So initial was 20, the change was 10, so 20 plus 10 is the final temperature, 30 degrees Celsius. We did it. You've reached the pair up. What I want you guys to do is copy down the text of this question, and this question. And we'll solve these in class tomorrow. I also need you to copy down these summary questions right here, which we'll solve in class tomorrow. So in your separate piece of paper for classwork, you should already have written the homework assignment, the aim, the do now, the pair up, and the summary. All of that should be on a separate piece of paper from your Cornell notes. Thank you for watching and have a great evening.